This lesson is on writing the equation of a conic given distance restrictions. I'm going to try and make this go as quickly as possible, but I have 5 slides that we really need to go over in order to make sure you have every case covered, and some of these problems get a little long, so I'll do my best. Here's a really quick summary again. We did this in the last lesson as well, so I just wanted to put that in there so you can kind of go back if you need to. We are going to use the definition of distance to write equations of conics. So, really quickly, the definition of distance, remember the distance formula, is the square root of x minus x1 squared plus y minus y1 squared. And that comes from an understanding of the Pythagorean theorem on a coordinate plane. So, if we want to find the distance from somewhere to somewhere else, essentially what we do is we figure out how far we're going in the x direction, how far we're going in the y direction, and then we take this distance, which is here, and this distance, which is represented by y minus y1 squared, or y minus y1, then we square them, add them up, take the square root. And essentially that's what's going on. Now, really quick, just to make sure we understand all of these things, the distance to a point is going to be just the straight up distance formula. So x minus x1 squared plus y minus y1 squared is the distance to a point. If we want to find the distance to a line, one thing we have to be aware of, the definition of the distance from a point to a line, or the distance from some location to a line, we always want to go and be perpendicular to the line. So our distance is going to be the shortest distance to the line, which is always perpendicular. So for example, let's say we're finding the distance from this particular point to this line. We would draw a straight horizontal line if we want to find the distance to any vertical line, which means that if we're finding the distance to any line that's x equals a number, or x equals some x value, what happens then is we are taking the square root of x minus x1 squared plus y minus y1 squared. But what's happening all the time when we do this is this y value doesn't change. So if you look at what's happening with this red dotted line, there is no change in the y value. There's only a change in the x value. So this y minus y1 doesn't change. So if we're doing the distance to a line, we're really only taking the square root of x minus x1 squared in this particular case, which is really just x minus x1. So we're finding some horizontal distance. Likewise, if we want to find the distance to a line y minus y1, we don't need the distance formula for that either. We're just taking the straight up distance y minus y1. So that example would be if we had some sort of horizontal line. Oops, that should have been an equal sign. Y equals y1, some y value, some number. Then we want to find the distance from a point to that line. What we're doing is we're finding the vertical distance, which is always going to be having no change in the x value, because we're never moving side to side, we're only moving up and down. So that's why that would be the case. Problem 1. For each point on an equation, the distance of the equation from that point 2, 4 is equal to the distance from another point 3, 7. So the square root of x minus 2 squared plus y minus 4 squared equals the square root of x minus 3 squared plus y plus 7 squared. Notice it's equal to means that the two distance formula expressions are going to be set equal to each other because those distances are equal. Since those distances are equal, we end up having the terms equal. The terms on the inside, they have to be equal to each other. And then real quick, if I have something like x minus 3 squared, remember that that is distributing x minus 3 times x minus 3. So I end up with x squared minus 6x plus 9. I just don't want to forget and have us like not be aware of what's going on. But since that's going to happen a whole lot in this lesson, I don't want to have to do that every time. So I'm just going to tell you that we have x squared minus 4x plus 4 when I distribute that one, plus y squared minus 8y plus 16 for that one, equals x squared minus 6x plus 9 plus y squared plus 14y plus 49. So now I have all of these. Notice that in this particular equation, there's an x squared and a y squared on both sides. So that ends up being kind of nice. Now, I'm noticing that I can add 6x to the left side, and I end up with 2x. I can subtract 14y over to the left side, so I have minus 22y. And then these two terms were 20, so I can subtract 20 to the other side. So this was 58 over on the right side. 58 minus 20 is going to equal 38. So I could have, dividing the whole thing by 2, x minus 11y equals 19. That is the equation of a line. I could rewrite it in slope-intercept form if I want. But basically what this is saying is if you have some kind of equation that's equidistant from 2 points, it's likely going to be a line. And in this case, it's a particular line. Number 2, for each point, the conic's distance. Oh, well, now we know that they're going to be conic sections from now on. The conic's distance from the point negative 1, 3 is equal to its distance from the line y equals negative 5. Remember that the conic that's equidistant from a point and a line is going to be a parabola. This should make sense because that's this will be the focus and this will be the directrix. So I have the square root of x plus 1 squared plus y minus 3 squared, and that equals y plus 5. Because remember, from the previous side, we have distance from a point and distance from a line. So now I can square both sides. If I square the left side, I end up with x plus 1 squared plus y minus 3 squared. And if I square the right side, I get y plus 5 squared, which I'm going to simplify to y squared plus 10y plus 25. Now let's continue. X plus 1 squared is x squared plus 2x plus 1. Y minus 3 squared is y squared minus 6y plus 9. And now I'm going to kind of rewrite this in a way that makes sense. So notice that the y squareds are going to cancel. And so I probably want to get this to be y equals x squared something. So I'm going to move all the y's over to the right side. So 16y. I'll leave the x squared stuff over on the left side. And then I have 6y. I already moved that. And then I have another 10, so I'm going to subtract 10. So 16y plus 15, and then that's equal to x squared plus 2x. Now, most of the time, what we're going to end up doing in these problems is we're going to actually just leave it in as we can simplify things as much as we can, but we're not going to like complete the square or anything else. So we will just leave it like this, and then we will indicate what type of thing this is. So this is a parabola. And this parabola just so happens to be a y equals x squared type parabola, so it's going to open up and down because we have a positive x squared over here and a positive y over here. So that's kind of how that will go. Number 3, for each point, the conic's distance from 2, -4 is 1/3 its distance from the line x equals -2. So x minus 2 squared plus y plus 4 squared equals, well, it's not quite equal to x plus 2 because now notice that this is 1/3 its distance. So typically when we see these problems, is means equals, and then 1/3 times x minus 2. So now I'm going to square both sides. I get x minus 2 squared plus y plus 4 squared equals. Now what happens if I square 1/3? I get 1/9. So I get 1/9 times x plus 2 squared. So now I'm going to distribute everything. So x squared minus 4x plus 4 plus y squared plus 8y plus 16 equals 1/9 times x squared plus 4x plus 4. Now at some point I have to distribute this 9, and in my opinion, it's wiser to not deal with fractions a whole lot. So I would take this, multiply it to the other side, and then distribute. I think that's a lot wiser because then you're not dealing with fractions all day long. So I have 9x squared minus 36x plus 36 plus 9y squared plus 72y plus 144 equals x squared plus 4x plus 4. So now let's subtract everything over. I have 8x squared minus 40x. Notice that 36, 144, those add together to be 180, and then I'm going to subtract a 4 over, so I'm going to have plus 176. And then I don't really have to do anything to the y's. So this is my equation. And then when I look at this, I don't have to get it into any other form or anything. I just have to decide what type of thing it is. This conic, notice that I have a positive x squared and a positive y squared, and they have different coefficients. So this is an ellipse. And if I really wanted to dig deeper into it and figure out what kind of ellipse it is, whether it's longer in the x direction or the y direction, that one would be longer in the x direction, because when we divided by some kind of common number, notice that the number below x would be bigger than the number below y when we divided everything out. For each point, the conic's distance from 1, 6 is twice its distance from the line x equals -5. So I have x minus 1 squared plus y minus 6 squared is 2 times x plus 5. So now when I square both sides, I have x minus 1 squared plus y minus 6 squared equals 4 times x plus 5 squared. 2 squared is 4, so that's something that's kind of important to keep in mind. X squared minus 2x plus 1 plus y squared minus 12y plus 36 equals 4 times x squared plus 10x plus 25. As I continue to do this, now a good decision would be to distribute the 4 on the same side it originally was, because now I'm still not dealing with fractions. So plus y squared minus 12y plus 36 equals 4x squared plus 40x plus 100. So now let's subtract everything over. I have negative 3x squared minus 42x plus y squared minus 12y, and then I have 37 on the left side, subtracting 100, that will be minus 63. I could rewrite this as 3x squared plus 42x minus y squared plus 12y plus 63 equals 0. Both of those are ways to write this equation depending on where you subtract things. But this is a hyperbola. Notice that there's an x squared and a y squared in this problem, and both of those things are both those things have different signs. Okay, now for each point, where'd you go? For each point, the distance from negative 1, 3 is 4 times the distance from 2, 1. So x plus 1 squared plus y minus 3 squared is equal to 4 times the square root of x minus 2 squared plus y minus 1 squared. So in this problem, we basically are doing the same thing over and over again, but we just kind of have to make sure that we know what's happening. So I'm going to square both sides. I have 16 times x minus 2 squared plus y minus 1 squared. And now this just becomes more and more of the same procedure. So here we go. X squared plus 2x plus 1 plus y squared minus 6y plus 9 equals 16 times x squared minus 4x plus 4 plus y squared minus 2y plus 1. Now I'm going to distribute the 16 on the right side. So I have 16x squared minus 64x plus 64 plus 16y squared minus 32y plus 16. Now let's combine everything. The right side is probably a better place for everything because then the x squared and the y squared will both be positive. So I have 15x squared minus 66x minus or plus 15y squared. Add 6y, so minus 26y. And then 64 plus 16 is 80. Subtracting 10 gives me 70. And when I look at this, I see that x squared and y squared have the same sign, and they are both, I don't know what just happened there. And they both have the same coefficient. So this is a circle.